9 hours. That is how long the Apollo 11 crew watched something they could not identify pace their spacecraft on the way to the moon. Not a glint, not a flash. A coherent object holding relative position, close enough that Buzz Aldrin later admitted on camera he was afraid to describe it in real time because he did not want to trigger a mission abort. Ground control offered an explanation. The crew accepted it. The mission continued. And for 57 years since, that explanation has quietly failed to close the file. Now, Artemis II is preparing to fly the same corridor through the same volume of space with the same tracking architecture and the same blind spot. This is not a story about a UFO. This is a story about what NASA still cannot see. Take a breath. Wherever you are watching this from, a phone at 2 in the morning, a laptop on a lunch break, a television with the lights low, I want you to sit with one uncomfortable fact before we go any further. The United States is about to send 4 human beings farther from Earth than anyone has traveled in over half a century, into a region of space that the agency responsible for their safety cannot actively surveil. Not will not, cannot. And that gap is not a secret. It is simply not the story anyone in the press office wants to tell you first. The Apollo 11 incident is the cleanest possible entry point because it is fully documented, fully public, and fully unresolved. On the outbound coast toward the moon, all 3 crew members reported an object visible through the sextant and the monocular telescope, tracking alongside them. They asked Houston carefully where the discarded S-4B upper stage was relative to their position. Houston came back with a distance in the thousands of miles. Whatever the crew was looking at was much closer than that. Aldrin, decades later, described it as either the S-4B or one of the 4 panels that separated from it during translunar injection. That is the official explanation. It is also, by his own admission, a guess. Because nobody on the ground could confirm what the crew was seeing. Nobody had a radar return. Nobody had a second data source. The identification was made by narrative process of elimination, not by measurement. That is the honest version, and it has never been updated. Which means, when Artemis II flies, the same identification method, a best guess from the ground, is still the state of the art. Now consider the version of Artemis II you have been given. A triumphant return. The first crewed lunar mission in over 50 years. A free return trajectory around the moon. 4 astronauts. A proving flight for the deep space program. The press materials are polished. The mission patches are sold. The politicians take their photographs. And the underlying engineering reality, the one buried in Government Accountability Office reports and NASA Inspector General audits, tells a very different story. Artemis I came back with heat shield damage that nobody predicted. Char loss in patterns the models did not forecast. In locations the ground testing had not flagged. At magnitudes that exceeded design assumptions. The investigation took over a year. The fix for Artemis II was not a redesigned shield. It was a modified re-entry trajectory to reduce thermal load. In plain language, they did not solve the problem. They flew around it. That is not incompetence. That is the honest way large programs manage unresolved risk under political deadlines. But it is not the story on the mission page. And it sets the pattern for everything else you are about to hear. The public frame is, we are back. The engineering frame is, we are barely back, and the margins are thinner than the language suggests. Both are true. Only one is being emphasized. This is what successful failure language was invented for. NASA has been using it since Apollo 13, and it has quietly become the default vocabulary for every large program whose ambitions outrun its budget. It is not deception, it is compression. But compression, repeated across decades, produces a public understanding that is materially different from the engineering understanding. And that gap is where the story lives. Here is the part that should bother you. The heat shield issue is the visible one. It made headlines because re-entry is dramatic and the damage was photographable. The invisible issues, the tracking gap, the communications architecture, the sensor coverage, do not photograph. There is no charred surface to hold up in a press conference. There is only a quiet operational reality that 4 astronauts are about to inherit, and a public narrative that has no room for it. The official story of Artemis II only holds together if you never ask how NASA sees what is flying next to its astronauts. And the answer to that question is the part nobody wants on camera. Because once you understand what the tracking architecture actually is, the celebrated return to deep space starts to look less like a triumph of new capability and more like a repeat of an old bet, one that Apollo won. To understand why 9 hours of tracking silence in 1969 still matters in 2026, you need to understand what NASA actually uses to see in deep space. The answer is going to surprise you. There is no radar dome sweeping the volume between Earth and the Moon. There is no orbital surveillance network out there. There is no equivalent of the air traffic control system that watches every commercial flight over your head right now. What NASA has is called the Deep Space Network. 3 enormous antenna complexes, positioned roughly 120 degrees apart around the globe. Goldstone in California, Madrid in Spain, Canberra in Australia. The geometry is deliberate. As the Earth rotates, at least one complex is always pointed at any given spacecraft. The largest dishes are 70 meters across. They are extraordinary instruments. They are also, functionally, ears. They listen for specific radio transponders on specific spacecraft that have been pre-registered, pre-scheduled, and pre-authorized to broadcast on specific frequencies. That is what they do. That is all they do. The beam width of a 70-meter dish at S-band is a fraction of a degree. Point 1 at the Moon, and you can resolve at any given instant a patch of sky smaller than a thumbnail held at arm's length. Everything outside that patch is invisible. Not blurry, invisible. There is no signal because there is no antenna listening to it. This is the architecture. This is what tracking means in deep space. It does not mean surveillance. It means listening to a spacecraft that has already agreed to be heard. Let that sit for a second. When NASA says they are tracking Artemis II, they mean they are receiving telemetry from Orion's transponder. They know where Orion is because Orion is telling them. Anything that has not agreed to broadcast, a piece of debris, an unregistered object, a natural body, a fragment of prior hardware, whatever the Apollo 11 crew was watching for 9 hours, is not tracked. It is not mistracked. It simply does not exist in the system. The Space Surveillance Network, run by the US Space Force, does catalogue objects, but its effective operational ceiling is around geosynchronous altitude, roughly 36,000 kilometers. The Moon is 10 times farther out. Everything between geo and lunar distance is, in surveillance terms, empty, because we cannot see it, not because it is empty in fact. That is a critical distinction the press coverage never makes, which raises a question the agency has spent 40 years not answering publicly. If we cannot see what is out there, how do we know what is out there? Here is the part that should bother you most. This blind spot is not new. It is not a technology gap waiting for a breakthrough. It is a maintenance failure that has persisted since Apollo, and no crewed program has ever funded the fix. The reason is structural, not technical. NASA is a science and exploration agency, not a surveillance agency. Its mandate is to send spacecraft outward, not to watch the volume they fly through. The Space Force is a military organization whose strategic interests currently stop at geosynchronous altitude, because that is where the satellites that matter to national security live. The commercial sector has no incentive to fund tracking infrastructure it cannot monetize. And so the gap sits there, decade after decade, program after program, administration after administration. Apollo flew through it. The space shuttle never needed to, because it never left low Earth orbit. The ISS orbits well below it, and now Artemis is flying back into it, using the same deep space network architecture with the same limitations, on the same operational assumption that has held since 1969. That the volume is big enough and the mission short enough that luck will hold. That is the actual doctrine. Nobody says it in those words, but that is what it amounts to. Wherever you are watching from, pause for a second and be honest with yourself. Before today, did you know that the space your astronauts are flying through cannot be actively scanned? Because most people do not. And the reason most people do not is that the coverage never says it. The coverage talks about mission timelines, crew selection, launch windows, splashdown coordinates. It does not talk about sensor coverage, because sensor coverage does not photograph well. The Apollo 11 record is the honest one. 3 trained observers reported an object. The ground could not confirm it. A best guess identification was offered. The crew accepted it because rejecting it meant aborting the mission that had defined a decade of American ambition. The entire episode was resolved by narrative, not by measurement. And every crewed lunar mission since, all 6 Apollo landings, and now Artemis, has flown on the same terms. This is not a mystery. It is a maintenance failure. Nobody funded the fix. Every crewed mission that flies through this volume inherits the same gap. Artemis II, Artemis III, Artemis IV, every commercial lunar mission that follows. Every international partner that joins the program. All of them flying through a volume where we do not see anything and there is nothing there are, operationally, the same sentence. And what NASA can barely see up close gets exponentially worse the further out you go. Here is where the intuitive picture breaks. Most viewers assume that a mission to the moon is essentially a longer version of a mission to the space station. Further out, longer trip, more fuel, more supplies, but the same general kind of operation. That intuition is wrong at every level, and the numbers do not just get worse, they change category. Start with radar. Detection sensitivity falls as the 4th power of distance. Double the range, and the return signal drops by a factor of 16. Go 10 times further, and it drops by a factor of 10,000. That is not a gradient. That is a cliff. A piece of debris that would produce a clean, unambiguous radar blip in low Earth orbit becomes invisible at a fraction of the distance to the moon, even to the most powerful ground radars we have. The physics is not being cruel, it is being consistent. But the operational consequence is that everything we know how to see in low orbit, we do not know how to see at lunar distance. Different regime, different category. Now do communications. Earth-Moon light time is about 1 1/3 seconds each way. Uncomfortable, but manageable. A conversation with a delay. Earth-Mars light time, at maximum distance, is about 22 minutes each way. That is not a longer conversation. That is not a conversation at all. That is 2 monologues exchanged across a gulf where anything urgent has to be solved by the crew alone. Because by the time the ground hears about it, the situation has already resolved itself one way or the other. Artemis II operates in the manageable regime, but it is the first crewed mission in over half a century to leave the regime where real-time help is possible at all. GPS does not exist beyond medium Earth orbit. The navigation infrastructure that every phone, every car, every airliner on Earth depends on none of it reaches the moon. Artemis relies on optical navigation, star trackers, and deep space network ranging. Sophisticated, yes. Redundant to modern terrestrial standards, no. Abort-to-Earth trajectories, the safety backbone of every ISS mission, become expensive, slow, and in some mission phases, impossible. On the ISS, if something goes wrong, the crew is home in hours. On Artemis II, if something goes wrong in the wrong phase of the trajectory, the crew is home in days, or not at all. Artemis II is not a rehearsal for Mars. It is a demonstration that our existing deep space infrastructure is already at its operational ceiling at the moon. That is the honest read. And the crew does not just fly through this blind zone, they live in it. And this is where the argument stops being about systems and starts being about bodies. The crew of Artemis II will spend roughly 10 days inside a spacecraft with walls measured in millimeters, traveling through a volume that our sensor network cannot survey, protected against micrometeoroid impact by shielding certified to specifications derived from limited empirical data. Every one of those clauses is defensible. None of them appear in the mission summary. Start with the physics of what is out there. Micrometeoroids in cislunar space typically travel at relative velocities around 20 kilometers per second. Some are faster. That is not a number, that is a category of energy. At that speed, a 1-gram fragment, the mass of a paperclip, carries kinetic energy in the range of 200 kilojoules. 200 kilojoules is roughly equivalent to a bowling ball dropped from a 5-story building. Except that energy is not spread across the bowling ball's footprint. It is concentrated onto an impact point smaller than a fingernail. That is a hole punch, not an impact. That is a projectile that does not care what your shielding is rated for, because it is delivering its energy faster than the material can respond. The Orion crew module has multi-layer shielding designed to stop objects up to a certain size at certain velocities. Above that threshold, the shielding is not rated. Not because engineers were lazy, because there is no way to test it at full scale. You cannot fire a paperclip at 20 kilometers per second in a laboratory and get a clean answer. The models exist. The models are calibrated against limited empirical data. The confidence intervals are wider than the press releases suggest. Now layer radiation on top of impact. In translunar coast, outside the Earth's magnetosphere, the crew absorbs galactic cosmic ray doses several times higher than ISS crews receive per day. That is the baseline. On top of the baseline, a single solar particle event, a coronal mass ejection aimed at the wrong volume of space at the wrong time, can escalate that dose in hours, without warning that reaches the crew in time to matter. Orion has a designated storm shelter region. The crew's protocol in a major event is to physically move into it and wait. Now hold both facts in your mind at once. A crew inside a vehicle we cannot fully certify against impact. Inside a radiation environment we cannot fully predict. Inside a volume we cannot fully survey. That is not a single failure mode. That is 3 independent risk architectures overlapping. And this exposure is not a bug in Artemis II. It is baked into every architecture NASA has drawn for what comes next. Now widen the frame. Artemis II is one mission. Artemis III lands humans on the lunar South Pole for the first time in history. Artemis IV assembles the Lunar Gateway Station in a near rectilinear halo orbit that no crewed vehicle has ever occupied for extended periods, in a geometry chosen partly because it minimizes fuel and partly because it accepts communications gaps that would be unacceptable at the ISS. Behind those missions is a projected surge in cislunar activity that has no historical precedent. Commercial landers under NASA's CLPS program, robotic prospectors for water ice at the poles, European Space Agency contributions to Gateway, Japanese pressurized rovers, Chinese lunar program hardware on an accelerating timeline of its own, Indian orbital assets, private sector cargo missions, South Korean, UAE, and Israeli spacecraft. The volume of space that Apollo flew through in near-total isolation is about to become the most operationally crowded region beyond low Earth orbit in human history. And the tracking infrastructure to manage that traffic does not exist. Not partially, not in draft, does not exist. The Deep Space Network is oversubscribed as it is. Its utilization has been running near capacity for years, with mission planners competing for antenna time and NASA's own audit reports flagging the scheduling contention as a systemic risk. Adding Gateway, adding lunar surface assets, adding commercial partners, all wanting antenna time on a network that was designed for a handful of concurrent deep space missions, the math does not close. There are proposals to expand DSN capacity. There are proposals to build lunar relay satellites. There are proposals to distribute the load across international partners. Proposals are not infrastructure. There is no international treaty on cislunar space traffic management. There is no equivalent of the International Civil Aviation Organization for the Moon. There is no shared debris catalogue. There is no agreed frequency coordination for lunar orbit assets. Every nation, every company, is planning its own operations on the assumption that the volume is big enough that collisions are unlikely. That is exactly the assumption that failed in low Earth orbit, where we now have tens of thousands of tracked objects, and the ISS performs collision avoidance maneuvers on a regular basis. The pattern is not new. The Space Shuttle program spent years accumulating infrastructure debt that was invisible until Columbia forced the ledger open. Aviation ignored radar until Tenerife. Maritime traffic ignored radio until the Titanic. Infrastructure follows disaster, never precedes it. Artemis is flying into that pattern with its eyes open, and the funding to prevent it is not there. So why isn't anyone at NASA saying this out loud? The answer is uncomfortable, and it isn't a conspiracy. The answer is an incentive structure. NASA operates on annual congressional appropriations in a political environment where any admission of program fragility is immediately weaponized by budget opponents. That is not paranoia. That is documented history. The agency learned this lesson brutally after Challenger and again after Columbia. Post-accident investigations in both cases concluded that internal engineering concerns had been softened, deferred, or normalized because raising them loudly would have delayed missions and threatened funding. That is not villainy. That is what happens when an agency with a decadal mission has to defend its budget every 12 months. The Artemis program has survived 3 administrations. Its cost overruns are measured in tens of billions. Its schedule slips are measured in years. In that environment, the phrase, "We are still analyzing the data," is doing double duty. It is both genuine ongoing engineering work and a rhetorical placeholder that buys time without triggering a political response. Both meanings are true simultaneously. That is not a contradiction. That is how institutional language works under pressure. The Artemis I heat shield anomaly is the cleanest recent example. The damage was real. The investigation was serious. The fix, modifying the re-entry trajectory, was a legitimate engineering response within the constraints. And the public framing was compressed into language that emphasized the successful splashdown far more than the unresolved thermal behavior. Nobody lied. The compression happened at the podium, not in the engineering reports. Anyone who reads the Inspector General audits sees the same picture the engineers see. Almost nobody reads the audits. Now here is the part that has to be said clearly, because the prosecutorial voice loses credibility the moment it drifts into accusation. This is not an argument that NASA is lying to the public. It is not an argument that the engineers are incompetent. It is not an argument that the astronauts are being sent to certain death. It is not an argument that the science is fake or the mission worthless. Every one of those claims would be false. The engineers are extraordinary. The astronauts have accepted informed risk that they understand better than any commentator ever will. The science is real. The argument is narrower and harder. The public framing of Artemis lags behind the engineering reality of Artemis, and that gap is where the actual risk sits, not in villainy. In the space between what is technically known and what is publicly emphasized. That gap has widened, quietly, mission by mission, for 60 years. Because the object itself was never the real story. The real story is what its non-identification tells us about where we are actually going. Now widen the frame one more time, because this is where the story stops being about Artemis and starts being about the next 50 years of human presence beyond Earth. Humanity is entering a new era of crewed deep space operations, without the surveillance, tracking, and situational awareness infrastructure that era requires. That is not a rhetorical claim. It is a documented conclusion in every serious cislunar SSA study published in the last decade. By NASA, by the Air Force Research Laboratory, by academic consortia, by the National Academies of Sciences, Engineering, and Medicine. The gap is understood. The gap is not closing. If anything, it is widening. Because the traffic growth curve is steeper than the infrastructure investment curve, and it has been for the entire duration of the Artemis program. The historical comparison here is uncomfortable but exact. Early commercial aviation expanded faster than air traffic control. The result was Tenerife. 583 people dead on a single runway because the infrastructure to coordinate two aircraft in fog did not exist yet. Early maritime commerce expanded faster than lighthouses, charts, and radio. The result was the Titanic. Over 1,500 dead because the infrastructure to coordinate ice warnings did not exist yet. Early automotive traffic expanded faster than road standards, signage, and licensing. The result was decades of preventable fatalities that only forced legislative response after the numbers became unignorable. In every case, the industry grew into a volume it could not properly perceive. In every case, the correction only arrived after specific accidents forced legislative and infrastructural response. In every case, the reports predicting the accidents existed before the accidents happened. In every case, the reports were read by the same kind of policymakers who will fund the fix for cislunar space only after the accident. That is the pattern. It has been the pattern for 150 years of technological expansion. There is no reason to believe deep space is exempt. Now hold the whole picture in your mind. A tracking architecture that listens instead of sees. A crewed program flying through a volume that cannot be actively surveyed. Shielding certified against models rather than measurements. A radiation environment that no forecast can fully predict. A traffic surge with no coordinating body. An institutional communication culture optimized for annual budget survival rather than decadal candor. And a historical pattern that says the fix comes after the crash, not before. The 9-hour object Apollo 11 tracked is not the anomaly the coverage treats it as. It is the earliest documented data point in a pattern we are choosing not to break. Which brings us back to those 9 hours and what they were actually telling us. Return with me to those 9 hours. 3 men in a small aluminium spacecraft watching an object they could not identify. hearing a distance from Houston that did not match what they saw through the sextant, deciding, collectively, quietly, professionally, not to escalate. Aldrin has said, on the record, that he was worried reporting it too clearly would trigger a mission abort. Think about what that means. A crew, alone, in trans-lunar coast, chose to swallow an anomaly because the cost of naming it was too high. And the ground team accepted an identification they could not verify, because the alternative was to admit they could not see what was next to their astronauts. That is the honest scene. That is the actual historical record. And the reason it still matters is that nothing structural has changed. The Deep Space Network is more capable than it was in 1969, but it is still an ear, not an eye. The Space Surveillance Network still stops at geostationary altitude. The cislunar volume is still uncatalogued. The MMOD shielding on Orion is still certified against models rather than measurements. The tracking gap is still a maintenance failure, not a mystery. When Artemis II flies, 4 astronauts will spend days in that same volume, and if they see something they cannot identify, the ground will offer them a best guess explanation drawn from the same process of elimination that answered Aldrin in 1969. The frightening answer is not that NASA knows and will not tell us. The frightening answer is that NASA does not know, cannot currently find out, and the architecture to find out is not being built fast enough. That is the verdict. That is what the silence was really saying. There is some good news, and it deserves to be said clearly. This is a solvable problem. Distributed cislunar sensor networks are technically feasible. Lunar relay satellites can extend both communications and tracking. International traffic management frameworks have been drafted. Debris cataloguing can be extended beyond geosynchronous altitude. None of it requires new physics. All of it requires funding at a scale current appropriations do not support, and political will at a level current incentive structures do not reward. The warning is not that we cannot fix this. The warning is that we are choosing, mission by mission, budget cycle by budget cycle, not to fix it fast enough. So the next time you hear the phrase "successful mission" attached to Artemis, remember what that phrase is doing. It is not lying. It is compressing. It is celebrating a real achievement while leaving out the structural risk that made the achievement narrower than it looks. The object Aldrin watched for 9 hours in 1969 has a name in the official record. That name is a guess. The next crew deserves better than a guess. Whether they get it is not up to the engineers, or the astronauts, or the mission planners. It is up to whether the people watching from the ground, including you, decide that seeing what is around our crews is worth funding before, and not after, we lose one.